Software Engineering Radio, episode 115, Architecture Analysis.
This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for support.
Welcome to another episode of Software Engineering Radio. This is an episode about software architecture analysis, and today we are talking to Bernhard Merkle. Welcome, Bernhard.
Hi.
So, Bernhard, I was about to say, why don't you introduce yourself to our listeners, but we got feedback which said that I shouldn't say, why don't you blah, blah, blah. So, please introduce yourself to our listeners.
Okay, thank you, Markus. My name is Bernhard Merkle. I'm working at SIG AG. The company name is real also for English native speakers.
Yeah, SIG.
So it's kind of funny, but the founder was Erwin SIG, and we are producing laser scanners. Mainly, we are the leader in the sensor area. And my job is in the central research and development department, software engineering, and I'm responsible for tool selection, development processes, all that kind of stuff.
And in that context, you have been evaluating and working with software architecture analysis tools in the recent past.
That's right, yes. We have looked at several tools, and we had also the problem that the software architecture of our program decayed over time, and I think it's a common problem.
Right. So the plan for this episode is to first outline the problem, which is basically the decay of software architecture, which all of you listeners probably know is a problem. And then we're going to look at the analysis tools and how they can help.
So why should we care about software architecture analysis? I think in lots of problems there happens architecture decay or architectural erosion of software. And as we will see, we are not alone in our projects. We have also some prominent representatives, even some well-known projects like Eclipse or like Java, which have some kind of architectural erosion. And the question is, how do you check architecture? Is there some process? Is there some tool that you are using? And do you care about architecture at all? I think in most projects, when you approach the release, you will build in workarounds, things like that, and you will violate the original planned software architecture, and later on you will not remove that violation.
Yeah. So the thing we're going to look at is that somebody, and we're not going to define who that is, the architect or an architecture team or an agile team, defines how the architecture should look like, and then we want to check whether the actual code conforms to that architecture.
Yes.
Okay. Before we do that, we should probably define what architecture is.
Software architecture definition I like is from IEEE, and it says the software architecture is a fundamental organization of systems embodied in its components, their relationship to each other and the environment, and a principle governing its design and evolution. And I think the important words are organization of the system, components, the relationship between them, and the evolutionary part of that process, because that is the topic where the most problems arise during projects.
Defining an architecture is easy.
Yes.
Keeping it alive during the project is not that easy.
Exactly.
Yeah.
And as we shall see later on, we will be able to formulate those topics like organization, relationships in rules, which we can check against our current code base.
I think there are two related topics we should briefly mention to delineate from what we're doing today. One is that software architecture documentation is not what we're talking about. Writing a Word document is not verifiable, right?
Yeah.
And the other thing is model-driven development. Can you say something how that relates?
I worked in model-driven development, and I'm also a big fan of the model-driven software development process. But I think it has also some limitations, especially on the tool side. There's not so much selection. There's upcoming support, there's Eclipse, there's open architecture, things like that. But there are lots of projects, at least it's my experience, which are developed in a, say, traditional way. So without models, without code generators. So people are hacking code in their editor, compiling it, and at some time they will violate the UML diagrams or model some other people have drawn for them.
Yeah.
And the model-driven software development approach is very good in my opinion, but it has some open items. For example, modeling languages. For most people, UML is too general, but there are only few IDEs which really support the DSL approach with its own meta model, etc. Also, another problem is good integration of legacy software. Should you reverse engineer? What do you get as additional information from the code level in the model? You need some kind of abstraction to gain something in the model.
I think that's the central challenge. I mean, if you do model driven, then I guess the need for a lot of this architecture analysis goes away. But if you do classical approach, or if you have legacy systems, then the model driven approach doesn't help you much.
And I even would extend that argument. Even if you do model driven software development, you have to verify with a certain approach that architecture is followed in your model. So you have some kind of model verification.
But that would be a different tooling.
Yeah.
So then let's look at the core topic of this episode, which is architecture analysis. You called it architectural linting. Maybe you want to explain where this comes from?
Yes, it comes from I think it's one of the oldest tool in the software development.
That's why I'm asking you. Our audience maybe doesn't know.
Yes, the lint tool is one of the static code checkers, which is, I think, around for about 20 years now. It's still there, PC lint, for checking C and C++ code. And the architectural analysis is a static analysis approach. So I called it also linting software architectures.
Right.
Of course, the static approach has some limitations. If you do things or tricks at runtime, if you use reflection in Java or DLL in C++, you can have some violations in your architecture that you will not be able to find with static analysis in the first approach. However, there is some tools, there is support that you can feed in information about what reflection is used, what classes are used, etc.
Okay. To further structure the discussion, you have come up with a set of levels or kinds of of static analysis, and we can use that to explain what we're doing here and what we're not doing. So I shouldn't say this. It's probably true. I say this too often. Why don't you explain those levels?
So I explain those levels. No problem. The goal on all levels is to find and avoid problems and to increase the quality and also to measure it. 3 different levels we can distinguish in static analysis. The first I would call micro level. It's the really code level, which you can check with rule sets like MISRA-C. It concerns things like code layout, brackets, certain risky statements that you should not do in certain programming language.
Check for null.
Correct. Yeah. The next level would be the macro level. This concerns things like class design, rules you know from books like Scott Myers, Joshua Bloch, etc., effective C++, effective Java. So that concerns things like you should pass by reference and things like that. So actually those macro level is more difficult to check than the micro level because it involves more intelligence of the programmer. So tools have difficulties to check that or are some kind of noisy at that level. And the interesting thing is at the next level, at the architecture level, things become easier.
Easier again,
On the architecture level of static analysis, we are talking about layers, graph architecture, layer architecture, subsystem, components, interfaces, and things like coupling between modules, dependencies, etc.
And just to connect to the previous episode on static analysis we've had, that basically looked at what you would call the macro level mainly.
Yes, correct.
So that was, building a state-based model of what the program does and that stuff. So that's that. And today we're talking about the the architecture level. What can you do with architecture analysis?
We can do different kinds of architectural analysis. You could also call them different use cases
Right.
for architectural analysis. One is consistency analysis. The idea is that you check the intended architecture as you originally planned it against the existing architecture, which is effectively your code base.
Right.
So you find some inconsistencies usually between them, and you have to deal with them.
Yep.
The second one is rating architecture. So you say something about the internal software quality of your architecture. Is there a high dependency coupling?
Yep.
Do you have anti-patterns, bad smells, things like that?
Yep.
The third one is discovering architecture.
Yep.
Maybe your project lead or your architect from the project has gone and there's no documentation.
Yeah.
It's not so uncommon.
No, I know.
Case. And then you have to discover the possibly, if there is one architecture.
Yeah. That's the reverse engineering thing.
Yes.
Yep.
Then another interesting topic is what I call measure the real facts.
Yeah.
In effect, this is collecting some metrics about your architecture, accounting packages, etc.
Yeah.
It's an important topic because you cannot control what you cannot measure, and I think most of the people are not measuring or do not collect numbers at all in projects.
Yeah.
Okay, and the last one is monitoring changes. Over time, you have some trend. The architecture decreases, packages are added, coupling is increased. When you're monitoring change, you have a chance to reverse the decay.
Yep. Okay, so we're going to talk through each of those 5 use cases. We're going to start with a consistency analysis. As we said before, the idea is to check the existing code structure against some kind of architecture definition.
Yeah.
That requires that you somehow define what the architecture should be. How do you do that?
You do that in kind of architectural language, which is at the moment tool specific.
Mm-hmm.
And even some of the tools, when we come later to the tools,
Right.
we'll see that some of the tools have even no way at the moment. But most of the tools fortunately have ways to define the architecture. So you don't use UML or some other modeling language. What you do is you, for example, in Java, you collect a package to a component and you say you are allowed to have dependencies between component A and component B, or only between interfaces to that component, things like that.
So you define that a set of packages, you define that to be a component, and then you do dependency analysis between those sets, aka components. Okay, right. Mm-hmm.
Yeah, that's the idea. So you define the should architecture in some kind of modeling, let's call it modeling language, or some kind of architectural language. It's not so formal.
It's actually a set of constraints.
Yeah. Correct. Then you extract the is architecture, on the other hand, from your existing code base.
Right.
So to gain the real information from that process, you have to have some parser that parses your bytecode or your C++ code and extracts the is architecture, and then you do a comparison and get a diff architecture and derive some actions.
Mm-hmm. And the action would be, you have to remove this dependency to conform to the architecture, blah, blah, blah.
Sometimes it may be possible to fix architectural violations. Sometimes it may even be impossible because you have delivered the interfaces to some clients.
Right. And once you get these actions, what you basically do is you do a refactoring of the architecture to conform to the rules.
Yes, you do a refactoring in the large, we call this. So it's not a refactoring on the attribute level or the method level. Essentially, it's a refactoring on the class level or package level or even component level. And you redesign, for example, some packages. You get information how much violation do you have, and you can derive some strategies. For example, if you have a bidirectional dependency, you can see where the number is lower and try to remove it in one way. Yeah.
So of course, what I really want is, in the Eclipse world, control F1. Or control 1 actually, and then quick fix, and then fix my architecture. Can the tools do that, or is it basically manual work to fix the violation?
At the moment, no. The tools could, for trivial cases, make some suggestions or some hints, but normally the intelligence of the designer is still needed.
Yeah. Let me ask one thing. I am a little bit so I am skeptical about. Okay, I agree that these tools are useful. No discussion. However, I kind of object to the idea as defining an architecture to just be a set of components and their dependencies. There is more to architecture than just dependencies. So my question is, what kinds of constraints can you actually define? You said before yet that you collect a bunch of packages into what you call a component, and then you'd say from that component there can only be two dependencies to interfaces in that other component. What else can you do? I mean, can you give us a couple of examples of the kinds of things you can check with these tools?
The tools even go further. As I said, there are additional aspects like, for example, anti-patterns or bad smells that you can detect. So if you have dependent base classes, certain tools are able to detect this and give you a warning, so you can remove this or try to remove that anti-pattern. Also, if you look at metrics, I think it's important to keep an eye on that area. You usually make a threshold and identify some outliers of that area and fix that. Classes with too much public attributes, things like that.
Yeah. What the tools give you is basically an awareness of the problem.
Right.
But you have to define what the constraints are, and you have to fix the problems yourself.
Yeah. So it identifies the violation, where it is, the quantity, how much.
Yeah.
The impact has to be determined by you, and also if the handling of the violations is possible, the tool can export a list with possible modifications. Right. So you fix them later, or you can even automate this maybe in future. And some tools even allow you to do virtual refactoring.
What's that?
You can move, for example, classes or packages in advance and recomputate the violations on the virtual refactoring. So you don't do this actually in the code, you do it just in a simulation and look if it gets better or worse.
So the way this works is that those tools actually parse the code into some kind of data structure database, and you do the refactoring on that data structure.
Right. And my experience was that, for example, a lot of violations can even be removed with moving some packages or some classes to other levels of a layered architecture.
Right. So I guess that concludes the consistency analysis part. The next one was the rating of architectures. What's that?
So the rating of architectures does not concern any external requirements. It concerns the internal quality of your software. So do you have cycles in the software? What is the stability? Do you have tight coupling, anti-patterns, bad smells, things like that?
So in that case, you don't define your own constraints and architectural rules, but rather the tool comes with a set of predefined smells.
Yes, the tool comes with a predefined set of smells and anti-patterns.
Right, and finds them in your code.
Yeah. Other things you can look, for example, is can I extract certain things from my architecture, or can certain modules be reused independently?
Yeah. If the tool comes with a set of predefined anti-patterns or smells, can it do automatic refactoring in that case then?
No, they're not yet there. They can, for example, detect a dependent base class, which is a common anti-pattern. Yep. And the interesting thing is that if you look at real code, for example, Eclipse or JDK, you can find that anti-pattern dependent base classes is nearly 2 classes per 1,000 in Eclipse 2.1 and 16 per 1,000 in JDK 1.4. So it's kind of interesting if you apply those tools to a large code base.
And again, in that case, the tool gives you a list of problems and or diagrams, or makes you aware of the problem, and then you fix it.
Yes, the representation are different among the tools. Some tools represent those things only in numbers, but some also represent them in graphical ways, because sometimes one or the other approach is more appropriate.
Right.
So if you draw, for example, the dependency of classes and packages that depends on each other, for example, in the JDK, you see nearly a big ball of mud when you look at a class.zip or the runtime.jar, which says something about the maintainability.
Yeah. It also says something about the notation, because it doesn't help you much. too much information, I guess.
It's too much information. Often the important point is to get the right things. So one important point is to drill down, for example, from component to package to class to the actual violation where it happens, and to go back to the top level. So that's the important point of aggregation. Right aggregation of the results and presenting them either in numerical or in graphical way.
So you can see the violations on a very, very macro level, and only if you want to know where the real problem is, you drill down.
Right.
As opposed to showing everything all the time.
Yes, because then you lose, you are lost in space.
The next topic is discovering an architecture. Again, I think it's mostly about making the users aware, visualizing things, right?
Yes. Sometimes the architecture is, say, implicit. So there's no good documentation, or the architecture left, the architect left the project. So you have no documentation of the existing architecture, and one use case is discovering an existing architecture in your source code. So that's not the main usage of those tools, but it's a possible use case.
Back in the days, there was a tool called Sniff++. Is it that kind of stuff?
It's that kind of stuff, but extended with additional things like, for example, graph layout. For example, if you look at interfaces or derived classes, you can see which clients are using me, am I used in the right way, which interfaces are not used at all. So I can adapt my API and make additional design decisions.
It helps you find stuff that nobody uses, so you can deprecate or remove it.
Yes. Of course, you have a high-level cross-referencer like you had in Sniff, and actually one of the creators of such an architectural analysis tool is Walter Bischofsberger, who did the original Sniff implementation at Take5.
Ah, I didn't know that. I knew that Walter Bischofsberger works on, I think it's Photograph, right?
Yes, it's Photograph.
Yes, but I didn't know that he was the Sniff person.
Yeah.
Okay, to discover the architect. Well, okay, here's the problem. Discovering the architecture is the classical reverse engineering problem, because you want to rediscover the intent of how the architecture should look like from the low-level code. And as we both know, that's not trivial. So how good are these tools? What can they actually do? Is it basically, again, defining components and then abstracting or aggregating things on component level?
They are pretty good at that job, I think, because they're using some kind of intelligent layout mechanism. For example, if you look at inheritance or core relationships, you can apply different graph algorithms and see the structure. So you see your central abstractions in a diagram on the one end, and the more concrete classes on the other end. So you can identify central abstraction mechanisms.
So what you're saying is that one of the big advantages of these tools is that they give you a very good visual clue of what's going on. They don't really infer much. They really just show you things in a way that you can infer things.
Yes.
Solves the problem of trying to understand what the original person wanted. Measure the real facts metrics. Use case number 5, I think.
Metrics are numbers, and numbers can also lie, but they can also say some kind of truth. So metrics are, for me, indicators of quality, understandability, maintenance. So measured numbers that can say something about your existing code base. Some trivial examples are lines of code, cyclomatic complexity, things like that. But I think more interesting are metrics like the invented from Robert Martin abstractness, instability, inheritance, depth, and things like that. Number of overwritten or implemented methods.
I guess the problem with metrics is that there are so many of them. So I think that the challenge is to select the right ones.
Right. The challenge is to select the right ones, to filter also them out. So you have to categorize them, and good tools don't just throw you with numbers. They categorize, present them in a way that you can use them in a useful way. But I think nevertheless they are important, because you have to do some measurement how your software evolves over the time. And I think at the moment lots of people are not doing this at all.
Is it fair to say that the real value of metrics is not their absolute number, but how they evolve over time? You know, is it bad that you have a cyclomatic complexity of 7? Or should it be 11? Or is 11 already bad? Should it only be 5? Isn't it more interesting to see that yesterday we had 5, now we have 7, tomorrow we have 9? is it the trend that is more important, or is it the absolute number? Because I tend to think it's the trend.
The trend is, of course, also important, but I think the absolute number also says something about your classes. So my experience was that outliers usually were also candidates that caused a lot of design problems or maintenance problems. Of course, there may be some good reason why there is such a number, and more advanced tools can even define a own quality model. So depending on your project, you can adjust the values, or depending on the programming language or component infrastructure you're using, for example, EJB, Corba, etc. You can adapt those numbers and filter out things that you're not interested in.
And the tools are able to monitor things over time, but I guess that's the next point, I think.
Most of the tools are able, and I recommend that you only use something that monitors that over time.
Yeah, I think that was probably a really good bridge to the next topic, which is monitoring changes.
So the idea is to see the trends, and as we saw in the last topic about metrics, it also influences your quality.
Yeah.
So with monitoring over time, you can see what new artifacts are coming into your project. You also see new dependencies, new architecture violations, and the idea is to correct those violations before they really burn into the code base.
Yeah, and it's the same thing with testing, right? If the test fails 5 minutes after you did something bad, you can still remember what you did. Same thing here.
Yeah. Also interesting is, I think, that most outsourcing projects I know of are not monitoring such things at all. So I think it's a must-have for controlling a project.
Yeah, I agree. So I guess this was the theoretical part, what the tools can do and what you should use them for. The next part of the discussion is looking at certain tools. You have evaluated a number of them, and we're going to talk a little bit about your experiences.
You can distinguish them with certain features. For example, some tools have methods to describe architectural rules, other just display the architecture as it is, and you don't have any means to formulate the architecture. They also differ in how they present the results, for example, in numbers or in graphical way. The granularity, IDE integration is also a topic. If you see the violation right in your Eclipse, it's much more easier. And also things like automation is scriptable, command line, IDE integration.
So let's define the optimal tool, right? What you want is you want to be able to define your own architectural constraints.
Right.
You want very fancy graphical layout to make you aware of what's going on. You want trend analysis.
You want IDE integration, and you want the tool to be easy to use.
Okay, well, and bug-free and fast and all that. Yeah, okay.
So some tools I've looked at is, for example, Photograph from Software Tomography.
Yeah.
That's a company we mentioned before. Walter Bischofsberger is the CTO of that. They recently merged with SonarJ. The company is called Hello Tomorrow.
Right.
So that's an interesting merger because, as we'll see, one tool is more developer-centric, IDE, and the other is more for the architect in the standalone version.
Okay.
So I think it's a good merger. Next one is Bauhaus, Axivion. It's a spin-off of a university. Then Structure 101 from Hathaway Software. Lattice. Clockwork is not mainly an architectural analysis tool, it's more a lint-like tool.
Yeah, I know we've had it on the list on the static analysis episode.
But it has also a small part where you can formulate or discover architectures.
Right.
And there are a bunch of open source projects we should mention: Xrudder, SAML Code, CodeGrower, CSoft, etc.
So, okay. Which one do you want to?
Of course, first we should mention there are even some basic approach that you can do something without tool support to avoid architectural decay. For example, maintain your make system. Look which dependencies you have. Of course, on a very coarse level. There are some simple tools like make-depend, JDepend, and for example, IDE-specific solutions like the Eclipse Java build path where you can enter patterns for packages that you can use or not use.
From how you talk, it sounds like you mostly work with Java. Are the tools Java specific, or are they generally language independent? And
no, most of the tools support some kind of Java and C, C++, and C Sharp.
Okay, so the typical stuff.
The typical stuff. Some also support additional languages.
Okay. So, Sotograph, first one.
Sotograph is, in my opinion, a very powerful tool. It's one of the most advanced, but also a complex tool. So you have some time to get used to it.
Mm-hmm.
It displays the infos via graphs and via numbers. It has some really useful layout algorithms.
Mm-hmm.
And it's known since, I think, 2003.
Yeah.
And as we said, the former Sniff++ guy, Walter Bischofsberger, is one of the main implementers and designers of Sotograph. So there's some deep knowledge in that area.
Yeah.
The data is stored in a MySQL database. You can access that. It's an open schema. You access that with a fat GUI client written in Java. There's a Sotograph and a SotoArc. SotoArc is a new tool, which was invented 2007. It's more user-friendly. And you have also a web report and a bunch of metrics, about 200, trend analysis, virtual refactoring, and parser for C, C++, Java, and C Sharp.
Any disadvantages except for the time it takes to get into it?
It's very powerful, and then that's also one of the disadvantages. So you can get lost, for example, in too much metrics. So you have to know where you want to look at.
Can you give us a feeling of the language that's used to define the architecture? Is it something OCL-ish, or how does it feel? You know, this constraint definition language thing.
Actually, there are two tools. Sotograph and SotoArc. In Sotograph, you used some kind of Java language. It was the Java bean shell, where you described which components are composed from which packages and to which layer they are allowed, and then you can define the constraints. And this was checked against the information in the database. Now with SotoArc, you don't do that anymore in syntax. You do that graphically.
No, you basically drag and drop things, and
and the description is actually generated into the former Soto.
So in other words, SotoArc is a graphical user interface to graphically define the specifications that you formerly wrote manually in Sotograph.
Right.
Okay. Next one is the what is it? The Bauhaus suite.
Bauhaus suite is from Axivion. Axivion is a spin-off of University Stuttgart and University Bremen. The tool itself is similar to Sotograph in many points. One difference, it's not database based, it's more file based, and it has not so easy user interface. The advantage is it supports more languages, for example, also Ada, COBOL, Visual Basic, and the tool itself, it's written in Ada. Maybe that's also in Ada. So maybe that's the reason that the GUI is not so nice at the moment.
Wow.
However, there's cool Python scripting, so you can integrate that in your continuous build process and mail, for example, the things you find out. It supports the usual things we discussed: architectural violation, architectural checking, metrics, clone detection, cycle detection, dead code detection. The difference to Sotograph is that you even can define the architectural rules on a more fine level.
That would be the macro level then.
Yeah.
SonarJ?
SonarJ is definitely a Java centric tool only. It has no graphs, and it's let's call it in-memory DB. So it has essentially no MySQL database. Everything is kept in memory. It's very developer centric. So it's a Eclipse plugin, and the architecture meta model is also manifested in the tool itself. So you have the vertical and the horizontal layer, and you divide the technical part in the horizontal and the business part in the vertical layer.
But the layers themselves are user definable.
They are user definable.
Okay. So it just has, so what's baked in the tool is the matrix basically, but not the specific set of layers like data access UI. Okay, that's not it. Okay.
And it has some basic support for complexity checks. So there are not so much metrics, but you can set some thresholds. There's no trend support at the moment. As I said, weak metric support, but it's very developer oriented, and it's as I said, it's an Eclipse plugin, and you get immediate feedback from the violations you are coding into the source base.
And that's compared to Photograph, where you basically, you pour the source code into it, it works for an hour and then gives you a bunch of diagrams.
Yeah. So next one is Structure 101. That's company in US and Ireland. They have a standalone client, which is Java based, supporting languages like Java and C++ in cooperation with Coverity. Coverity is a static analysis code analyzer, and programming research is producing QAC. So they're in cooperation with them, and I think a ADA version is planned also. Results are represented as dependency structure matrix, as in lattice, so numbers in matrix, and also in a graphical way. What's interesting is they have also a web application called Structure 101 Tracker, and they have even some repository on their website where they analyze open source, the architecture of open source projects. So at the moment, I think you find about 10 or 20 projects which are checked there at a regular basis. It's the same approach that Coverity does with static analysis of C and C++ code for open source projects with the SCAN initiative.
And why are they doing it? Is it to show off their tool, or is it to do a favor for the open source tools, to do them a favor and tell them where their problems are?
I think it's both.
Okay.
Maybe more the first topic to gain more visibility in the market. But I think it's a good idea to offer this for open source projects for free. And even Spring, for example, is a well-known framework in the Java enterprise market. And Spring, for example, is checked with Photograph and SonarJ.
Okay, the lattice.
Lattice is essentially based on numbers, so you have no graphics support. Also, the import is some importing source code is some kind of weak, in my opinion. You have no real C++ parser, for example. It's done via Doxygen or Microsoft BSD files, which is very platform dependent. No real database in memory. You get you can realize some kind of trend support if you build it yourself via command line. So that's not built in. However, some people are using it, and I think for simple projects and for projects with a clean architecture, it scales. But for really grown projects with lots of violations, it's difficult to use. So the idea is you have a matrix, and in that matrix you say who is depending on me, and the column shows using relations and the row shows used by. And then you can group the artifacts in subsystem and layers and arrange them in the matrix. They have also an example where they show the architecture of the ARNT make tool, which is known for Java. And the interesting fact is, even in ARNT, there were some violations over time, despite the fact that it's reviewed by lots of people.
Clockwork?
Clockwork is not an architectural analysis tool in the first place. It's known for its static code analysis capability, but it has been extended, and it displays also the things via graphs and tables. The layout algorithms are very weak at the moment, so there's no out-of-the-box functionality where you can say arrange this with a Spring embedder algorithm or things like that. But you can implement it yourself via tickle scripts, which is not an optimal approach in my opinion.
You say I shall implement my own layout algorithm in Tickle.
No, the filtering of the the filtering of the information will be implemented in Tickle, and I think they rely on consulting to do that at the customer side. They support Java and C++. It's also a Fat GUI client, and they also have a web report. Of course, there are some open source tools, as I mentioned. SAML code is at the moment also coming up. It's a Java only solution and not so performant at the moment, but we'll see how that evolves in over time. Also, even Google has some additional plugins for JDPand to formulate rules. So there are also some open source alternatives. However, I should mention our experience was it took us 1 week to get the numbers via JDPand and sort them out to get an overview of a real existing Java application, and in the same time with another architectural analysis tool we were able to refactor and remove most of the violations in the tool.
You're saying that it probably is a good investment to buy the commercial tool because the open source tools aren't there yet.
Yes. And it pays off, I think, very quick. However, you have to obey the learning curve at the startup.
Okay, so let's wrap this up with a couple of take-home points.
So I think today's IDE and build mechanisms are not suited for architectural analysis. You have some basic support, some open source tools like JDPand, but in my opinion, if you do real stuff and want to keep an eye on the architecture and maintainability of your application, you should use architectural analysis tool. So tool support, I think, is very important. It's the same with coding guidelines. You can have your 10 pages coding guideline and nobody reads it. You have to check this and enforce it automatically. Otherwise, it's just a document and laying around. I think also the management can be convinced if existing problems become visible. It's an important point. I think the quality of architecture, internal software quality, doesn't pay immediately. It pays on the long term, and it's difficult to convince the management to invest in internal quality. And unfortunately, the topic comes up usually when it's too late, when the application is not maintainable at all, or when you want to remove some module and you drag that module and everything comes behind. Also, rules will and can be violated. There's also a good reason for that. We talked about interfaces have been released to clients, to customers, and then you can say, okay, this rule will, there is a deviation, I accept this, and don't bother anymore.
So the tools are able to remember that I don't want to be bothered anymore. You check something and then it goes away. It's not showing up again. Okay, so Bernhard, thank you very much for being on the show.
Thank you.
Thanks for downloading and listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example by clicking on the Dig, Reddit, Delicious and Slashdot buttons. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under a Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.